Welcome back to our live training session here with our Honda EP3 Civic. This training module, we're going to take a look at completing our calibrating and tuning process with this K24 engine and do a flex fuel based tune. This is higher compression, about 12.5 to 13:1 compression, and we're able to run this on 93 octane, and we have to be conservative with the spark timing. So we're going to see if we can sneak additional spark timing in and make additional power as a result with our engine, doing it in a safe manner, running ethanol fuel. Currently, I'm just on 93 octane with a little bit of ethanol blend in the fuel, and that's pretty typical for United States. We're not going to have pumps that are ethanol free in my area here. So anywhere between 9 to 12% is pretty normal of what we would find with ethanol mixed into 91 or 93 octane. So let's take a look at what I have going on within the programming here so we can jump in and understand the flex fuel based tuning and what we're trying to accomplish. So first things first, we have to set up a flex fuel sensor. We've already done that and tested it earlier in previous training modules, but for right now, let's look at the reading of our composition in our fuel system. So how much ethanol is currently in the fuel system. We can go here into channels and we go down. I have a parameter here called fuel composition sensor. We can see it's currently reading here about 9.3, 9.4%. That is going to be accurate. So we see that that's falling in line of what I would expect to have coming out of the normal pump petrol fuel here in my local area. So I have a little bit of ethanol in the fuel. What we're going to do here is actually drain out the existing amount of fuel. Looks like I have a little bit less than a half tank of gas here in the vehicle. I'm going to show you how to use the fuel pump option to pump the fuel out of the tank. I don't have a drain on the tank itself. It's still running all the OEM lines and tank. It is a return LaSalle system and it's sealed up pretty well. So I actually have a feed line that's going to be an aftermarket feed line. I adopted to a hard line on the firewall, and that's where the flex fuel sensor is sitting on the feed line. It's sitting between those two. I'm going to pump out the fuel using and jumping out the fuel pump. We'll discuss that here in a little bit. And I'm going to run all that fuel out. Then I'll fill up with about 5 to 10 gallons of ethanol. Now, I am on a winter blend ethanol, which is usually between 70-75% total ethanol content. So we'll find that between what we have residual in the fuel tank that I simply can't pump out, plus what I put in for ethanol, we'll probably be sitting somewhere along the lines of about 50 to 60% ethanol content. That's the highest I'm going to be able to get it. Now, if I had E98, pure ethanol, I'd be able to put some in there and bring up my ethanol content, but I can't, unfortunately, so we're gonna have to see whatever it ends up with our ethanol content. Ideally, in order to really take advantage of running additional spark timing, we'd like to see at least 70% ethanol content. Once we get up to about 70%, we're really getting the most knock suppression out of running ethanol, and higher ethanol amount doesn't necessarily translate to be able to run more spark advance or more horsepower and torque production out of our engine. So what we're going to find here is that we're going to be below that 70% range. We may not be able to add all of the spark timing we'd like, but we should be able to sneak in a few degrees of timing to make additional power safely. That is where we make the power with ethanol, being able to generate more cylinder pressure and being able to do that in a controlled manner without having to worry about knock or pre-ignition. So if you're on a turbocharged engine, you'd be able to increase your boost pressure and or increase your timing. Naturally aspirated, all we can do is bump up the spark timing in order to make additional power. Now, ethanol fuel itself can sometimes just make a little bit additional power compared to petrol fuel, just injecting without doing any actual tuning changes other than compensating for the fueling difference between petrol fuel and working with ethanol. So sometimes there's a power gain there by the cooling effect of the fuel itself. But what we'll find is that we usually gain the majority of the power with our spark advance. And we'll talk about how we're setting that up and how everything's going to be working here. So our flex fuel sensor has been configured already. We know that it's registering and reading and working. Now we can turn our attention into the setup and configuration of a couple tables that are really critical for allowing the flex fuel sensor, the flex fuel control here in the Motec to work properly. First and foremost, we have to have the basics in line to make sure we have our flex fuel tune going in and compensating for when we have higher ethanol concentrations. Let's go talk about that here real quick. We're gonna go from our tuning area here and go into setup. Now we're gonna go move here into basic setup, and we can take a look. Our alternate fuel mode is set to flex fuel. Our alternate fuel properties calibration is set to ethanol 1.0. So we're telling the Motec that the other fuel that we're going to be running and blending between is Petrol fuel is our primary, and then the alternate fuel is going to be ethanol. So we can see that's represented right here. And we're saying we're in this flex fuel mode, meaning we're going to be looking at the flex fuel sensor and allowing the Motec to make updates and changes to this. Now, when we select here that we have our properties for ethanol, that's going to make sure that it's accounting for the density and the fuel stoich of up to 100% ethanol. This is important because if we take a look back here, and this is going to be what handles the fueling difference, meaning as we go from petrol fuel into working with higher ethanol concentrations, Motec's going to automatically compensate in the background for us because we've specified the desired target lambda here from our target aim table, and then it's going to take our value here, it's going to multiply it by the fuel stoich that it's looking up. So based on how much ethanol content, it'll have a different fuel stoich value. It multiplies the target lambda by the fuel stoich, and that's going to get us a new target air fuel to use within the airflow modeling equation. Fuel mass is equal to air mass divided by target air fuel. We know our air mass registration comes from our VE table in all of the calculations. Knowing air mass, we simply divide by the new target air fuel. That's going to get us a new fuel mass, and therefore a corrected injector pulse width. So as long as we're modeling everything correctly here with the Motec, it knows the ethanol content, and therefore it knows the correct fuel stoich, and therefore it's able to automatically correct within the fuel and airflow modeling equation for ethanol fuel. That's how that works. Now, there are some other factors here. When we select the option for ethanol fuel, it takes a look at the density of the fuel and the cooling properties of the fuel, the latent heat of vaporization, and it takes that into account in terms of the modeling as well. So it's going to be a sliding scale between petrol fuel here as our primary fuel source, our secondary fuel in our system here for the flex fuel option is ethanol, and it'll be able to look between these two in order to determine what the proper fuel stoich and fuel properties will be. Pretty simple there. So that's first and foremost what we have to get out of the way. Now we also have here under our advanced inputs, we've set up, looking down here at fuel composition sensor, we've set this up on a universal digital input. Our hybrid A option was set to the continental sensor. That's what I have installed in here. We then have our fuel temperature. If we go up here under the universal digital hybrid B, so it's determining our fuel temperature, which is important for our fuel modeling within the Motec. Even if you're not doing a flex fuel based tune, I highly always recommend adding in a flex fuel based sensor, simply because we're able to track then the content level and then the fuel temperature. It's really important into the calculations, and it's easy enough and the sensors are cheap enough to add to the Motec in order to get this parameter here. You can tune without a flex fuel sensor and a fuel temperature reading, but it is more accurate, including the fuel temperature. It tracks things correctly and be able to account for the density of the fuel as the temperature changes. So we have the basics accounted for here. Now let's talk about some specifics with our flex fuel tuning. First and foremost, let's talk about our fueling differences. So we just discussed how Motec handles going in and compensating for whatever the ethanol content is going to be, having additional fuel flow added through the fuel injector. So generally speaking here, if we go from pure petrol fuel to pure ethanol, we need about 40 to 45% more fuel flow. It's able to do that just purely looking up the new fuel stoich and including that in the air and fuel model. But we'll find that we do have some other further corrections than we do account for, and that's going to be typically our cranking fuel needs to be substantially higher in a cold engine with ethanol fuel due to the poor atomization coming out of the injector in a cold engine. If we go in here and take a look under tuning, we have our startup fuel window. We have our cranking fuel table. We know this table was working fairly well when the engine was cold or warm. Now this table is based just on coolant temp and engine crank cycles. What we need to do here is add additional layer to this and allow us to go in and use this for, let's say, 9-10% ethanol blended petrol fuel. So this is essentially our petrol map, and then have a separate table that we can interpolate between when we have ethanol-based fuels. If we go here and click A, we can actually add that in here. Fuel composition. Now what I'm going to do is set this table here for a 10% reference. So 10% ethanol and less, we'll use this table here. We'll clear out that option right here. We'll say 10. And then we're going to set one here to work with 90.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.